guys read a little bit about what a t-distribution was last night, talking about inferences in chapter 23. So give me one thing that you pulled from what is a t-distribution. Give me anything that you read about. If you're not even sure, grab a book and look at it and tell me now. Isaiah, tell me one thing. Okay, so you use t-distribution. There's something to do with the standard deviation, and we'll deal with what that is. It has to do with population standard deviations, and there's an issue we're going to talk about next class about whether you pool or don't pool, and it has to do with whether or not you know the population 1 standard deviation and population 2. That actually has to do with two different, I'm going too fast. That actually deals with 2 samples with means. We're not going to worry about that right now. There is something to do with standard deviation, though, yes, with this particular distribution. Let's even take a step back first, even further, before we jump into formulas and different things. When do we use a t-distribution? Nope. Nope. What have we done with inference, with every single thing has always been a what? A proportion. Everything we've done up until this point has been a proportion. We've talked about the percent of people that believe this, the percent of people that believe that, the 10 out of 20 people think this. Okay? That has nothing, we don't use the t-distribution with proportions ever, do we? Okay? When is t-distributions used? When we're talking about means. That's a big deal. Okay? So when we're talking about a comparative essay, that's one big difference. Would you agree? Normal distributions are used with proportions, and t-distributions are used with means. Give me something else that you read about that was different about t-distributions. What about the shape of them? Are they similar shapes as normal distributions? The picture on page 523 is a good picture. They're similar shapes, okay? So similar shapes to normal. But there's a little bit of a difference. So you might want to look at what is the difference, okay? And I'll let you talk about that. What is the difference in their shape? Because there is one, okay? Has fatter tails, okay? Awesome. You're leaving me hanging. I want your knuckles. I'm going to sit here until you give them to me. There you go. All right. So there's fatter tails. Similar shape of fatter tails has to do with sample size, okay? So sample size is something that we're going to need to worry about when we talk about t-distributions. The story that was talked about here, I think it was talked about. Did they talk about the beer situation? Was that in this one? Yeah. So was it Mr. Adams? Yeah, the Guinness Beer brewery guy. Okay. So you can imagine if we're trying to decide whether or not our beer manufacturer has like a quality control person, and we're trying to make sure that we're moving forward, we've done the right thing. Why do you think our sample size can't be less than 10% of our, can't be a certain size here? Why can't we have a large sample size in this case? Someone's got to taste it. And if we taste a lot, what do you think by the end of our tasting, we're going to oh, it's great, So we have to be real careful. That's actually how it came, that's actually how it came to be, to believe it or not, okay? So we have to really think about, we had this person, this mathematician, Gossett is his name. He decided, he kind of created, not created, but he found that you can use a smaller sample size and use a different distribution to make, and you can still find these things the distribution's still going to exist. It's called Gossett's T, okay? What else did you notice about the Gossett's T? It has to do with sample size. There was something mentioned that we've never really seen before until now. Anything unusual? Yeah, what is that? Degree of freedom, okay? So that's something that we got to discuss. And I want to see, by the way, all the things I have on the board are things I expect to see in your essay, okay? I'm kind of just putting keywords down. These are the things I want you to address. Does that make sense? Okay. So, oh, I just wrote degree of freedom. So what is a degree of freedom? How many degrees of freedom are there? There's an infinite number, okay? Just like there were an infinite number of normal distributions. Remember that? They all can various shapes, and I mean, they're all the same shape, but you can have a skinny tall one or a kind of a squatty wider one. But there's an infinite number of normal distributions, the same way with t-distributions. What do degrees of freedom do? What is a degree of freedom? How is it related to sample size? There's a formula for it, believe it or not. What's the formula for it? Okay, so the degree of freedom is n minus 1, so we have a formula. N is what again? Sample size. So it's 1 less than the sample size. That's a formula for it. Okay, and it just talks about the degree of freedom is that, when you're talking about a degree of freedom, it's that specific t-distribution that we're looking at, because there's an infinite number of them, right? So we can have this particular one has this fat tails, this one has this fat tails. So we're just talking about which distribution we're talking about, okay? That gives us kind of, it narrows it down for us. If you have your book, and it looks like most of us do, if you flip to the very, very back, there are some tables, okay? And I just want to kind of show you for a minute the tables. We've actually never used them. I'm going to try to find where they are. They're in the very, very back. There we go. Appendix G in the very, very back. You will see a Z table. And before the use of calculators, we actually, so Hunter, can you just come sit up here so you can see at least what I'm talking about, and you and Sammy can look with me? Okay? Just sit here. Just sit. It's not a big deal to sit next to Sammy. He doesn't bite. So we have Z tables here. Do you see that? These were actually used in place of the normal CDF function on our calculators back in the day, okay, back when I went to school. Right? They actually still give you these tables on the AP test, but there's really no need to use them because everything we need is in our calculator now, right? But those are there. You can give you your Z value. You can figure out what the probabilities are, and using, like if you have a Z score of negative 2.13, you can figure out where that would be, and that would be the probability for it. Okay? But if you keep flipping, you will see a t-distribution somewhere. There we go. Table T table. Okay, it's on my in my book, it's on A-120. Is that where yours is? My teacher's edition might be different than yours. 80? Okay, A-80. That's fine. It should say T table. Notice on the left-hand side, you have that whole column of degree of freedom. Do you see that? Degree of freedom is what you need to know based on, and then your probabilities will be on the middle. Okay? So that's what you're looking at the probabilities. That's not true. Because your probability can't be greater than 1. So degree of freedom, your values are in the middle. Okay? So just wanted to kind of show that to you. We'll also get to a chi-squared. If you look at the next page, I think it must be A81 on yours, right? That's called a chi-squared. We'll look at that one as well. But we're not going to really use the tables too much. I just wanted to show you that they're there. Okay? But degrees of freedom are important, and they relate, and they're important on which t-distribution we're going to be looking at to come up with that answer. Okay? All right, thank you. So, keeping and looking at that, what else is degree of freedom necessary for us to be able to find? Oh, goodness. What else is necessary? What else is the degree of freedom necessary? The degree of freedom is necessary to find what? What do we need it for? If you look on page 528, it tells you. What is the degree of freedom used for? I'll give you a hint. This notation that you see, what does that mean? What does that mean? It's kind of, T-star is like our Z-star. It's going to be our critical value with T distributions specifically. But the degree of freedom is this number down here notationally, okay? So your critical value is dependent on your degree of freedom. That's where I was trying to go with that. Okay? So your degree of freedom is important to be able to figure out what your critical value is. In other words, when you had normal distributions, wasn't there just basically you had 1.96, 1.645, you had specific Z-star values that we used over and over again, right? That doesn't happen with T's, okay? Because the degree of freedom will be different almost every time. So that's going to be important, okay? So we'll talk more about that on Monday. But in your comparative essay, you know that degree of freedom relates to, or is dependent, I'm saying it the wrong way. Your critical value is dependent on your degree of freedom. Okay? All right. What other things did you come up with when you were looking at this chapter? Anything else? Did you notice some similarities, Maddie?
For one of the differences, the nearly normal condition.
Okay, and so there's a new condition that's been introduced. Okay, so we're going to introduce, so there definitely is a new condition for that. Not only was there a new condition, but I think there's new formulas, wasn't there? So we have new standard deviation formulas, or at least different than that from proportions. Would you agree? So we have different formulas. And the formulas, let's see, do we remember what they are? So the new condition was a nearly normal condition. So we'll talk about what that means. Is that the only one that was different, Maddie? Because we still had randomness, 10%, but we don't have the NP is greater than Q anymore. Or, sorry, NP is greater than 10 or NQ. That's only for proportions. There was something else. Wasn't the... Oh yeah, just those three. Okay. Yes, just those three. Okay. So the new condition, we took out another one for proportions. We minus one and we added one. What formula was our formula for standard deviation? So standard deviation of means, we're talking about means this time, was what? Your state population standard deviation divided by the square root of n, wasn't it? And sometimes we know it and sometimes we don't know it. I think that's kind of what you were addressing, Isaiah, at the very beginning, right, when in terms of standard deviation. Sometimes we know this, but most often we don't, right? Most often we do not know what the true population standard deviation is. So most often in this case we'll be finding a standard error. I think that's what you were trying to say. Is that right? No? Sort of?
Yeah. I mean, like, I thought that we're finding the standard deviation.
You are. That's what that is. You're dividing by your sample size. And when you're using your sample standard deviation, that's a standard error. That's what you're saying. So you're saying, we're saying the same things. Yes. Yes, Daniel.
Standard deviation.
S is the sample standard deviation, which means, so that's what we're all saying the same thing. It's a notation, okay? No, that's okay. So basically this is if I knew the population standard deviation. Half the time I don't, right? So we're going to be finding the standard error, right? And that would be S divided by the square root of n. S is our sample standard deviation. And that's what I think we're all trying to say, is that most often we're here, right? But the point is that it's different than this one, isn't it? Wasn't that the formula we used for proportions? And so we're not using that formula anymore. There's still a formula to use. It's just different when we're talking about means. Okay? Any similarities that we found? There's lots of differences, I agree. Any similarities? We wrote one, didn't we? They have similar shapes, right? What is another similar thing between a normal distribution and a t-distribution? Nothing normal? Nothing normal. Nothing the same? Nothing similar? Okay, they both, there's still the t-distribution can still be used to find a confidence interval, which means there's still going to be a margin of error that's used. We're still going to use that similar formula. But with a t-distribution, we're talking about means. What would your confidence interval formula be? What's the statistic that we would use? Would we be using p hat anymore? What would we be using? The mean, the sample mean. That's our statistic, plus or minus t star now, because now we're worried about this. I'm going to go ahead and write it with df, meaning that's the degree of freedom that we need to know. Okay? So that's just our test statistic, right? And then we have, would you agree? So that's going to be our confidence interval. It's the same, I mean, that's why on your formula sheet it doesn't give you the exact letters. It gives you words because it's going to change depending on which test we're using. It's always your statistic plus or minus your critical value times your standard deviation of the statistic. Okay? So it's the same thing every time, it's just that sometimes we're plugging in different numbers into stuff. That's all. But a similarity, they both have one, or can be used into one. All right, what else? Is that enough? Does that give you enough to help you put the essay together? Feel like that's enough information? Anything else we can add, or? It needs to be cohesive. I have a minimum expectation of writing. Good. So you know how to do it, is my point. All right. Okay, so I'm going to go ahead and stop here. If you guys want to spend the rest of time, have the rest of time to use it to write it, that's fine. Okay, is that helpful? All right, anything else I can answer for you? We good? You feel comfortable? Have you taken your quiz? Did you take it yesterday? Why aren't you taking it?